Today, let's quickly try to understand abstract data types and how they are related to data structures. What is a data type? It is a way of grouping data items. All these data items have one or more common trait. In programming languages, particularly the strongly typed ones, data types are the basic building blocks with which the compiler or the interpreter of the language is able to validate and optimize programs. Data types in those languages are associated with variables, functions, and enable the compiler to know how much memory to allocate to a variable, what operators can be applied on those variables, and what operators can't be. And finally, optimize the storage for those variables. Examples of data types are int, boolean, float, long, etc. Basic types in programming languages are called primitive types. Using primitive types, we can also build complex types. Examples of complex types are arrays, which are grouping variables of same type, structs and unions, which are grouping variables of different types. But there are two problems with primitive types. Problem number one, in primitive types, the data items are syntactically separated from the operators that work on the data. Primitive types don't encapsulate data and operators. So, as a programmer, it's difficult to know what operators are supported for a given type unless one has a deeper understanding of the programming language. Problem number two, they are tied to a programming language. Abstract data types solves these two problems for us. Abstract data types tie together data items and operations. They explain operations in terms of mathematical equations. Abstract data types don't care about storage model for the data items. Abstract data types just provide a specification for a contract that developers can use to design their application. What is used to put this mathematical theory into practice? Data structures. Data structures are implementations of abstract data types. Now, data structures depend on primitive, complex types of programming languages to provide a concrete shape to the mathematical model of abstract data types. They also use primitive operators and built-in functions to provide concrete shape to the operations defined in the abstract data types. Let's take an example and try to define a fraction as an abstract data type. The mathematical model for a fraction consists of a numerator and a denominator represented as a pair. We can define three operations, add, multiply, and negate, in terms of their mathematical formulae as shown here. Coming to the implementation, two possible ways of representing the model in C language are structs and integer arrays. Both of these work equally well, though struct solution is more readable. Data structures have to worry about pointers, arrays, structs in a programming language, while an abstract data type is not tied to a programming language. Abstract data types have their counterparts in Java, C++ in the form of interfaces and abstract classes. They are the favorites of software architects and an essential part of their toolkit to ensure highly decoupled software systems. Thank you.